Hello friends, we are in the module number 5 and in this session we are starting with the first chapter, instrumental methods of analysis, and we'll be discussing about the potentiometric estimation. Okay, so let us come to the topic. What is this instrumental methods of analysis? Okay, so generally the analytical chemistry deals with the chemical analysis. What is this chemical analysis? How can we carry out? The chemical analysis can be carried out by two methods majorly. Which are they? One is the qualitative analysis and the other one is the quantitative analysis. What is this qualitative analysis? Like in PO you should have done, right? Okay, salt will be given. Okay, you will be finding out where it is dissolving and you will be carrying out some reactions. Okay, and when it is giving positive results, you will be just determining the given compound is so and so, the given compound is sodium chloride, the given compound is potassium, like that. Okay, you are just determining. That is a qualitative analysis. You are just determining the compound. Okay, and then what is this quantitative analysis? In the quantitative analysis, you are finding out the amount of the substance present in the given solution. How can we carry out this quantitative analysis? Quantitative analysis can be carried out generally by the titration methods or by gravimetric methods. Okay, in titration method, what will happen? We will be taking the standard solution in the burette, and in the conical flask, we are taking the analyte solution, and we need to add suitable indicators, okay, to see the completion of the reaction, and it will be showing the either the color to colorless or colorless to color or formation of turbidity. Any visible changes will be shown when we add the indicators. Okay, and we will measure the amount of the standard solution required. From that we can find out the amount of the given substance present in the given solution, right? And here when the reaction is over and the excess amount added only will be giving the color change. The reaction is over between the titrant and titrate. The excess added solution gives the color change. So we have added something excess, right? Okay, and even in the gravimetric methods, we are adding suitable reagents to make a complex. Okay, and that complex is filtered. It will be washed many times with the hot water. Okay, and then it will be dried, and finally it is weighed as a compound only, not in individual substance. Okay, so in these two experiments, there may be errors. Okay, in the analysis we cannot say that we got 100% accurate results. Okay, we may be adding slight excess amount. Okay, that is showing the results. So we cannot say it is 100% accurate. Okay, so instrumental methods of analysis came into existence. In instrumental methods of analysis, what will happen? The chemical signal is converted into the electrical signal. Okay, like for example, we are doing the potentiometric estimation. Okay, here we are using the electrodes to sense. Okay, indicator and reference electrodes will be there. Okay, whatever the changes that is happening here in the beaker will be sent to the device potentiometer, and we are measuring directly the potential of the redox titrations. Okay, in acid base titrations, we are measuring the pH of the given solution, like that. Okay, the chemical signal is converted into the electrical signal. Okay, which can be measured by using a suitable devices. Like in potentiometry, we are measuring the potential. In conductometry, we are measuring the specific conductance of the solution, and in a colorimetry, we are measuring the amount of the light absorbed. In the flame photometry, we are measuring the amount of the light emitted, like that. Okay, different examples are there, right? So it is clear, I think. In the instrumental methods of analysis, chemical signal will be converted into the electrical signal that can be measured by using a suitable devices. Okay, so in this first session, let us start with the potentiometric estimation. What are these potentiometric estimations? These are the determination of the concentration of the substance in the solutions. Okay, in potentiometry, potentiometric titration, we will be measuring the potential when the titration is in progress. Okay, what is the principle here? We are measuring the potential of the solution when the titration is in progress. Okay, initially what happens? There will be a gradual increase in the potential and near the equivalence point. Okay, what is this equivalence point? In titrations, we call this as a end point. Okay, end point may be slightly higher. Okay, equivalence point is 100% accurate. When the experiment, when the reaction between the titrant and titrate is completed, immediately you will be seeing the sudden jump in potential, change in conductance, like that. Okay, so by using these values, we are plotting the graph, and from the graph we can find out the amount of the substance present. So in instrumental methods of analysis, we will be getting almost 100% accurate values. Okay, So generally when we say what is this potentiometry, it's a determination of equivalence point of a redox titrations on the basis of potential measurements is called as a potentiometry. Fine. And coming to the instrumentation of the potentiometric experiment, it consists of a digital photo potentiometer will be there. Okay, here we are using the indicator electrode, platinum electrode, and we are using a reference electrode. We can use either calomel electrode or silver chloride electrode. Okay, both comes under reference electrodes. We can use any one of this. Okay, and these two are dipped in the analyte solution and are connected to the potentiometer device, right? Okay, and here the potential will be depending on the concentration of the metal ions. Okay, according to the Nernst equation, E is equal to E naught plus 0.0501 by N into log of Mn plus. Okay, so that potential is depending on the concentration of the metal ions. Fine. And examples for potentiometric reactions are redox reaction. Okay, here we are finding out the amount of FAS present by using a standard potassium dichromate. Okay, acid base titration example is a determination of pKa by using a weak acid. Okay, so let us take the redox titration potentiometric estimation of FAS by using standard potassium dichromate. Here in this experiment, we have to fill the burette with a standard potassium dichromate solution, and in beaker, FAS solution will be given. To provide the acidic medium, we have to add 1 test tube of H2SO4, and we are using the electrodes platinum and calomel electrode. Okay, and these two electrodes are dipped in the analyte solution and are connected to the potentiometer. Fine. And what will happen here? We have to mix the solution first by bubbling or by using the magnetic stirrers. Okay, and you have to note down the initial potential. After that, you should keep on adding 0.5 ml of the potassium dichromate from the burette. Okay, mix the solution gently and note down the potential after each addition. Okay, initially potential will be increasing, and near the equivalence point there will be a sudden jump in potential. So what exactly happens in the potentiometric experiment? We are having ferrous ammonium sulfate, FAS, in the beaker. Okay, after each addition of the potassium dichromate added, the ferrous ammonium sulfate will be converted into ferric ions. Okay, I said you it's a redox titration. What is oxidized and what is reduced here means FAS, ferrous ammonium sulfate, Fe2 plus is oxidized to ferric sulfate. At the same time, chromium ions Cr6 plus is reduced to Cr3 plus. And initially, we will be measuring the potential for Fe3 plus and Fe2 plus system. Okay, and as the titration proceeds, what will happen? All the FAS is completely oxidized to ferric ions. So no more ferrous ions will be there. All are oxidized to ferric. Okay, when all the ferrous ions are oxidized to ferric, okay, there will be a sudden jump in the potential. Okay, by using these values, okay, we are plotting the graph by using delta E by delta E values against the volume of the dichromate added. So when we plot the graph of delta E by delta V values against volume of the potassium dichromate added, we will be getting a peak like this. Okay, and from that we will come to know the equivalence point. This is the equivalence point. From the equivalence point, we can calculate the amount of the FAS present in the given solution by doing this calculation. Normality into volume of the FAS is equal to normality into volume of the potassium dichromate taken. Here volume of the FAS is given and we know the normality of dichromate and volume of the dichromate from the graph. We need to calculate first the normality of FAS. Okay, so we will get the normality. And after once you get the normality, multiply it by the equivalent weight of FAS, you will be getting the amount of FAS present in the given solution per liter. Okay, so in this way we can find out the amount of the substance present, okay, for the redox titrations. Fine. Okay, the applications here are, it will be giving a 100% accurate results. Okay, 100% accurate results will be obtained in the potentiometric experiments. Fine. And next we will be meeting with the conductometric experiment in the next session. Until then, thank you.